Good afternoon, everyone, and welcome to the webinar From Data to Impact, Scaling Sustainability Across Manufacturing Enterprises. My name is Danielle Close, and I'm the Conference and Registration Manager here at NAM. Before we get started, I'd just like to take a few minutes to familiarize everyone with the online components of our meeting today. At this point, many of you have joined into our session and should see the introductory screen here. If you do get bumped out of the session for any reason, simply repeat the login instructions to rejoin us. During this session, all participant lines are open, so please mute yourself to avoid any background noise. For questions, please type them in the chat, which can be accessed by selecting the speech bubble icon on the upper right corner of the Teams window. Questions will be answered at the end of today's session today, but you are encouraged to submit them throughout the webinar. If you cannot stay on for the duration of today's session, an electronic archive of this event will be available and you'll be sent download links as soon as they're ready. With those details out of the way, I'd like to take you a few moments to tell you more about NAM and our session today. We know that everyone has a busy schedule, and so we thank you for taking the time to be with us here today. At NAM, we provide a chance to benchmark our own programs, learn tactics to apply your own challenges, and build a network of fellow EHS&S professionals. We aim to accomplish this goal through an abundance of resources. We have 4 to 5 peer-led conferences a year, webinars, and unique benchmarking research reports. NAM facilitates your ability to network with the professionals who are leading the top EHS&S programs in the world. We have more than 100 companies and thousands of individual members in our membership, so engaging with NAM is a great way to benchmark your program, as our members represent a multitude of industries, sizes, and locations. This webinar is a part of our Affiliate Council webinar series, where we get insights from our partners in the Affiliate Council and focus on pressing challenges, emerging strategies, or specialized topics. I just want to take a moment to introduce our 2 speakers today. Sebastian Burke is a local LCA expert at Makersite, where he applies cutting-edge science-based methodologies to help organizations develop data-driven strategies that reduce environmental impact and enhance resource efficiency. Kevin Dillman, PhD, serves as a sustainability solutions engineer at Makersite, where he delivers innovative strategies to help organizations advance their sustainability initiatives and achieve compliance with evolving regulatory standards. Without further ado, I would like to hand it over to our speakers for the duration of our meeting today.
Great. Thank you so much for that introduction. So I'm going to steal the slides over and begin the presentation that we have prepared for you today. I think everyone should be seeing my slides now. Is that correct?
Yes.
Great. So thank you all for joining this webinar today. My name is Kevin Dillman from Makersite, as introduced, and with me today is Sebastian Burke, and we'll be jointly leading this presentation, in which we're going to be talking about From Data to Impact, Scaling Sustainability Across Manufacturing Enterprises. So what we're going to do is probably cover a challenge that many of you are likely facing today and why you're joining this webinar. And what we're going to go through is just kind of discuss, how the Makersite solution is doing this, but also in general, how the industry can move towards really working to move across scale as we're doing this. Just as a super brief introduction of who we are as Makersite, we're a software as a service company. For those who aren't necessarily familiar with us, 160 employees. We have headquarters both in Germany as well as Chicago in Europe. We have a wide range of customers in a variety of sectors across Microsoft, Barco, Canon, 3M, just to give kind of a rough feeling of some of the customers that we might be working with, and some might be also, kind of connected or tangential to your fields. Another thing that we do is also partner with softwares such as PTC, as well as Siemens Teamcenter, which are product lifecycle management tools. This is going to be important as we talk about scaling across manufacturers, because working with PLMs or your other ERP systems is really how you work to go from working on one-off LCAs to really moving across your product portfolio and scaling those LCAs across your product. So that tends to be kind of a very useful way to start to think about how do you start kind of moving from those one-offs and kind of crawl, walk, run your way to scale across product portfolios. And that's exactly what we're showing here is essentially how we do that and how other tools are capable of doing this is thinking about the customer data and trying to understand where does this information live. So you want to move across your systems. And what we're trying to do is basically harmonize and contextualize your data to think about, where do your bill of materials live? Where does your manufacturing process information live? If you're thinking about scope 3.1, also, your purchase orders, transactions to understand how does that scale across your corporate missions. And what we're really trying to do is then marry that to a variety of supply chain data sources. These include LCA data sources such as EcoInvent, World's Meta Metal databases, carbon mines. And what we're really do is connecting all this information that you have from your bill of informations, your bill of processes, manufacturing data, etc., link this up to LCA data. And then what we're going to use is AI and machine learning to essentially get you this variety of outputs. It can be 150 plus outputs, but really what this allows you to do is think about sustainability, compliance, cost, and supply chain risk. And these are all things that we're thinking about and become increasingly important as you think about LCAs at scale. I know this was the brief introduction, but now we're going to talk about why is this important. And that's because manufacturers facing a headwinds, we see kind of a different interpretation across, let's say, geographies, where within the EU, there's a lot of regulatory compliance that's coming into this. So when we talk about EPDs, especially in the Nordics and the construction sector, DPPs are becoming an increasingly important topic for manufacturers in order to kind of trace that variety of different product information, as well as regulatory and material compliance with REACH and RoHS. Versus in the US, it's maybe a little bit different. And what we're really seeing it is much more kind of related to customer decarbonization demands, SBTI targets, different RFPs and tenders that, are increasingly kind of requiring, it's increasingly becoming a business requirement to have this type of PCF and carbon data. And this really gets, that's why we were kind of talking about this as a data problem, because you're trying to pull data from so many different locations within your company. And how do you really kind of achieve that at scale? And that's what, we work to try to achieve. And I'm sure that many of you within your companies are trying to achieve of how do you kind of move from these data silos to a centralized kind of data location in which you can kind of respond to all these variety of requests. Because exactly to this point, reporting is becoming increasingly unmanageable. Maybe what started as these global reporting initiatives and, kind of much more focused approaches that maybe you're going to put into your sustainability report, like reporting for greenhouse gas protocol, scope 1 and 2. Scope 3 is increasingly becoming a priority, aligning with SBTI. You also have CDP that you need to comply to. And then there's regulations that are, kind of coming forward, for example, like CBAM, CSDDD, CSRD, DPP, Green Claims Directive. So, it kind of increasingly showcases the difficulty of reporting to all these kind of variety of frameworks that are existing. We all know the, kind of alphabet soup that's being created with all the acronyms that are coming into the marketplace. So what we really need to do is kind of focus on, well, how do we kind of bring all this data together so you can reliably report to all these different regulations in a scalable and auditable fashion. And so what you need to do is really kind of increase the current data coverage. Well, right now, customers are, our customers and what we're seeing in the marketplace is that typically you're pretty good, manufacturers know their product information, have a generally pretty good understanding of the risk associated with maybe the different materials or supply chain risk. And of course, cost, you know what you're paying for. And I mean, of course, you're always trying to kind of optimize and understand this cost better. But where the less understanding or where the bigger challenges kind of still lie in the marketplace as we see it is within the compliance side, getting supplier data information and doing this kind of in a scalable way without leading to supplier fatigue of constant surveying and trying to gather this information. And then lastly, of course, is the sustainability information, where a lot of our customers or a lot of people that we're talking to often maybe have this sustainability data, maybe for a couple of products, but how do you really achieve having, say, sustainability data at scale? And that's really the challenge that, we're here to talk about today, basically. And really, how do we see it is that we understand that material compliance and sustainability can have these similar requirements. For example, product compliance, you need to understand kind of the material and chemical properties of the product. And what are you able to do with that information? Well, you're also able to have product sustainability. You're able to do PCFs, LCA, eco design, if you're understanding these materials. And then so that becomes also important when you're talking at the corporate compliance level, because now if you know your product sustainability at scale, you can start to move away from your spend-based approach for scope 3.1. You can be reporting to CBAM. You can think about green procurement because you understand your supplier data better. So this is really how we see kind of the evolution moving from compliance to, really kind of scaling up your ability to reply on the sustainability side. And why do companies want to do this? Well, of course, because, the business impacts related to this are increasingly becoming tangible and important. We could cover a whole scale of them, for example, the Dieselgate or EV kind of like laggards. But, if we focus on just some of the greenwashing claims in which, for example, Eni was fined 5 million euro for greenwashing, for competitive reasons, for example, closing the market share gap that was seen by P&G, or for Apple non-compliance, which led to basically had to withdraw these AirPods from the Swedish market due to not material non-compliance. So this just kind of showcases some of the business risks that are apparent, and there's many more of these which are probably not reported that are increasingly important as you're trying to kind of increase market share and have your kind of desired place in the marketplace. So what do you really need to do to achieve this as well? What we see currently or is the status quo is a lot of companies understand their own emissions. They understand their own scope 1, scope 2. But what they're lacking is kind of that supply chain visibility and ability to kind of make decision making based off of this supply chain. So that's what we essentially want to kind of like move away from this just single corporate understanding into this kind of deeper supply chain visibility that will allow you to look beyond just tier 1 suppliers, but actually look down the supply chain. And this will help you strengthen your regulatory compliance, kind of report on your sustainability and ensure that you're kind of sourcing the right products and right materials that you want to, kind of have in your products that will give you the best, kind of business outcomes, sustainability outcomes, and compliance outcomes. So you're able to do this in a variety of ways. So, by doing so, what this gives you is kind of enablement of eco design. It allows you to have this kind of preservation of market access. And then lastly, it helps you unlock these supply chains, ensuring that you're able to have this sustainable sourcing and allowing you to also decarbonize your products as you're moving across this at scale. And why, of course, are you doing it? If you're thinking about the different departments and why the benefit that it gives to them, is that, of course, because falling behind has its consequences. So, I mean, most often the ones who are thinking about this are your sustainability experts, because, of course, they're thinking about the product design. They want to understand how can we improve the greenhouse gas emissions, think about the corporate emissions. But it's increasingly becoming important, for your salespeople. As we mentioned, increasingly it's becoming a business, kind of requirement in order to sell into markets is that you do have this kind of PCF, LCA information available to you. Product managers want to have this data available in order to enable their sales department. And then, of course, product engineers also want to be able to make those right decisions, but they don't often have that information at their fingertips. So that's why it's important as well to integrate with those CAD tools or those PLM softwares to enable product engineers as well to think about the sustainability of products pre-design as opposed to kind of just post-design and post-mortem. You've already made this product and now you're selling in the marketplace and maybe you have the LCA for it, but you don't actually have the ability to kind of change those impacts pre-design. So that's really what we want to think about and talk about here today. And so now I'll switch over to my colleague Sebastian, and he will lead from here.
All right, thanks, Kev. Yeah, I wanted to get into it a little bit more, looking at the service offering and zero in on the specific use cases that resonate most with our audiences at Makersite. While we've touched on the high-level strategic needs to stay competitive and compliant and sustainable, we're equipped to deliver what you need and want now. So for various key roles in your organization, Makersite offers tailored use cases that directly address your organization's priorities. This overview here highlights primary topics across business disciplines that Makersite is designed to address. And it's also equally important to us to clarify what Makersite doesn't do, right? So while our platform is comprehensive, we're not here to replace your existing ERP or PLM systems. Neither is Makersite a consultancy firm that simply hands off a report and then leaves you to figure it out. Instead, we're a strategic partner providing the data intelligence and tools that you need to make informed decisions and drive sustainable and profitable outcomes. That's how we look at it. And so whether you come to this with a specific need in mind or are unsure of exactly what you need, Makersite is designed to meet you where you are as a company and as a software. And we provide the tools and insights that not only fulfill your initial goals, but also should prepare you for the challenges and opportunities that lie ahead. And looking at some of those opportunities and challenges in the next slide, Kev. As we look at the Makersite offerings across different business topics, it's important to note that the software's capabilities for carbon reporting, but also for the reporting on more extensive environmental profiles exist. So what we draw up here is a spectrum, if you will, between the narrowly carbon-focused product carbon footprints, PCFs, and life cycle assessments, LCAs, and their condensed siblings, environmental declarations, product declarations, EPDs. So of course, both are tools used to measure and communicate the environmental impact of products, but they differ in scope, purpose, and the information they provide. And I'm not going to spend a lot of time, but I quickly want to put this on the record. So for PCFs, the scope focuses exclusively on the greenhouse gas emissions, right, associated with the product throughout the life cycle, cradle to gate, cradle to grave. Their purpose is to measure the carbon footprint, to understand, report, and ideally reduce the climate impact of the product. And PCF-specific standards guide the development of those underlying studies. On the other hand, LCAs and more for specifically the EPDs, their scope provides a comprehensive overview of various environmental impacts of a product system, not just carbon emissions. In fact, their exact purpose is to offer a larger profile of environmental performance to show possible trade-offs, right, between impacts. And here too, specific standards are available to guide the analysis. So you're likely familiar with both of those assessments already, which leaves us to note that Makersite offers multiple ways to conduct PCF and LCA EPD studies, to analyze results and to report them to your key stakeholders. So there are some major differences that we like to make sure to point to based on our comparison of Makersite's PCF, LCA, and EPD solutions to alternatives out there. Those differences are captured in these three visuals. On the left, with Makersite, there typically is a higher investment at the beginning, but after the initial system setup, the cost is consistent and remains easy to plan for Makersite as a software as a service. It's only software related. Of course, our team is available and human, but our customers can and do work in Makersite autonomously. In the middle, another difference is that the initial investment pays off because the amount of time that is needed to cover a certain part of a customer's portfolio is significantly shorter with Makersite. That is due to the integration and automation aspect of Makersite. Once all the data has been integrated up front, practically hundreds of results, including EPD results, can be created with the push of a button. And of course, customers love that. On the right-hand side, while EPD solutions out there are often very limited to only that particular purpose, i.e. being a solution for EPDs, Makersite was designed from its inception to cover not only LCA as a use case, but also compliance, chemical compliance, substance management, and also costs and other topics, if desired, all in the same software, and even based, at least partly, on the same data. So that has proven to be an innovative concept that leads to a lot of synergies and added value once implemented. So we're getting a little bit more specifically talking about LCAs at scale. Leading into it is what we've observed over the 30 plus years that LCA has been around, the expectations for lifecycle assessment have been quite dynamic. Different types of industries and manufacturers have seen varying needs and applications arise for results and for analysis, while the foundational layers of LCA have remained relatively constant. Meanwhile, the absolute demand for LCA has only increased, whether due to product volume or complexity or shortage of experts. So visualized here, the pressure on LCA has been intensifying as data scalability has become an objective, trying to speed up manual and individual efforts. However, there is a point where scalability is simply not accurate enough, especially with mature large manufacturers where scalability is achievable, but a lack of accuracy of data can make it counterproductive. So this points to a threefold solution providing expertise and scalability and accuracy for us. Those three aspects need to be clearly in sync and functioning properly, allowing internal expertise to scale with needs while maintaining consistent data accuracy, right? We at Makersite call that LCA at scale, and we're delighted to see that a growing number of organizations have found a solution to this building pressure in Makersite. Makersite's LCA at scale has been positioned on the LCA maturity curve by a group of sustainability software and consulting veterans, of whom I am one. I've been in LCA for more than 10 years. Makersite is designed to serve as an inclusive and anticipatory solution that keeps the demand for data analysis and reporting manageable. Taking over from self-built stuff and keeping data safe and organized, even as in-house responsibilities shift, teams change, and core knowledge fluctuates. I'm sure many of you know what I'm talking about there. Makersite is built on the realization that seamlessly sharing and working together beats a desktop-based patchwork. So just a couple more slides until we actually take a look at what Makersite looks like in real life. Makersite's intentional approach of LCA at scale is that data is ingested at once for everything, ideally, directly from the source system, and automatically transformed and mapped to third-party LCA databases in Makersite, and then to ultimately create a model for each product and component. So since the models are automatically generated, that makes them easy to reproduce with consistent quality. And as all products can receive a digital twin, product variations are captured by design, eliminating the need for scenarios. That compares to traditional LCA, on the next slide, which features one model with scenarios, is comparably hard to reproduce, maybe error-prone, definitely is labor-intensive and slow, and often can result in an average that is representative more of a group than really a specific product. So on the other hand, LCA at scale is easily reproducible and fast. And if there are errors, then they're usually found and caused by inconsistencies in the source data, which is easier to address, and the manual work is largely avoided. If you're wondering how companies get started with Makersite, we have some information here just to give some orientation about the typical journey into using Makersite. This is a schematic that highlights the different scopes our customers choose. Oftentimes, our customers explore Makersite through what we would call pre-implementation activities, where we work together on limited pilot scopes to apply and demonstrate the software, and then and learn about the approach together. And once our collaboration has led to mutual understanding and a shared vision, full implementation follows, which brings the solution to the customer's larger portfolios and puts the software in the customer's hands. One of the big prerequisites for this is proper data management. So we'll interject here with a slide that points at the importance of proper data management. So we're finding in our work with customers that those with well-organized, stored, and maintained data have a significantly easier time getting to use cases and analyses that are efficient and scalable and easy to verify. And on the flip side of this, at times, also it becomes apparent in our work that situations where we are coming on board, we're finding that LCA at scale can serve as sort of a wake-up call and an indicator that improving a company's data landscape will unlock new levels of understanding and strategic management and will enable more efficient and better, faster work in Makersite. So last slide. To illustrate the value of good data as a last point at work in Makersite, here's a key example. So in our customers' work with Makersite, a centrally important set of data is represented by a bill of materials or BOMs. Product carbon footprints and EPDs are each calculated along each branch of the BOM. So the BOM, typically consisting of materials, masses, or other units, is in Makersite and as needed, enriched with processes that are used to manufacture the product. So that standard process provides a full picture of how a product is made. In that process, we also use the power of integrating to 100+ databases. Some of them represent the best available LCA databases to assign emission factors and impacts to materials and manufacturing steps. And once the emissions and other impact potentials are calculated for each component in a BOM, then it becomes possible to use this information to calculate the emissions for any line item on an order from a supplier. And you can see where this is going. This shows really the synergies that are opened up by good data in Makersite, as LCA work can enable crucial Scope 3 Category 1 results generation, for example. So how does it work in Makersite? Kevin is going to show us.
Great. Thanks for that, Sebastian. So obviously we've shown a lot of slides just kind of like thinking about this conceptually, but so now we want to showcase what this looks like in Makersite, and not necessarily for the point just to kind of flash features, but rather to kind of like provide food for thought to think about how to think about really thinking about LCAs at scale and sustainability at scale, and thinking about this through kind of a scalable PCF solution. So first, what I'm going to show in Makersite is I'm just going to flash 4 screens, and I'm going to go through each one of them. But the first one is just to talk about kind of scalable matching. The second one is going to talk about how this becomes useful for engineers and why you want to end up doing it. The third will be showing how you're able to utilize this for Scope 3.1 reporting, kind of connecting to what Sebastian was just showing on his slides. And then the fourth one is going to be showcasing how what type of outputs are useful from this type of tool that should allow you to kind of provide outputs to your customers who are kind of demanding this type of LCA or PCF solutions. So the first thing I'm going to show you here is this matching screen, but it helps if I'm going to show you a little bit of context. So first I'm going to show you this blender. And hold on, I want to make sure that I'm sharing this correctly. You are seeing an Excel file map right now, right? Sebastian?
Excel document is what we see, yeah.
Yeah, okay, great. Just wanted to make sure I was sharing the screen and not the application. Great. So we are so now we're looking at the blender. And so this blender is essentially, this is what it looks like when we take a bill of material. From our customers, this is likely what it looks like inside of your product lifecycle management tool or ERP system. And what we typically see are these leveled kind of data, and you typically want to understand that so you can like kind of interpret what are the different components that you're using. The next thing that you want to look at is when you're thinking about LCAs at scale is how good of coverage do you have on your material information and on your weight information. Anyone who's done LCA will tell you that these are kind of the core data points that you need, because you need to know what material do you have and how much do you have of it in order to run these calculations. And now the next step is to think about, well, what other type of information can you bring in? And this might help in terms of manufacturer part numbers. If you're in the automotive sector, there's IMDS, which is kind of ways in which suppliers share material information. That's something that we can talk about maybe in the Q&A. It's kind of like a complex, deeper set, but it's basically using part numbers from your suppliers that kind of create automated LCAs and fill those gaps. But really, we just want to showcase, these are the typical type of data points you want to bring in, and you want to start thinking about that at scale. How do we bring that in? If you do have data gaps, some of the best things to do are work with your PLM systems or your CAD designers and make weight and material a required field. Because if you do that, you're going to have this information a lot more on hand, and it makes it a lot easier than, what we see with customers who are potentially struggling to have this information, is that a lot of this data lives in kind of PDF design documents, and it's extremely difficult to kind of pull that data out of. So those are some of the key steps that you can take. If you're being really clever and kind of want to work backwards, you might be able to potentially use large language models to kind of extract that information and fill it out in your system. But, that's kind of like a future looking way to solve that problem. But really, this is how the type of data that you would want to bring in. Next, what I'm going to do is now show this in Makersite and kind of show you a little bit what it does. So these are the different BOM leaves that were within the bill of materials that we're looking at, the leaf being kind of the lowest level of analysis that we're going to look at. And then you can see that, for example, this jar, we're looking at the polypropylene granulate, but you'll see that there's injection molding here. So what we do is use AI and machine learning, and this is something that really, if you're thinking about scaling, becomes really important. Because if you're talking about working across 100,000 different BOM lines, there's no way that anyone is going to be manually kind of filling in, okay, it's this material, let's connect it to this eco-invent process or connect it to this manufacturing process. So we have to start thinking about ways to kind of automate this process. So that way you can actually scale and start making decision-making across your portfolio, as opposed to, kind of the current state of working on this one by one, manually mapping this, manually inserting into the software. So what we want to showcase is really, of course, we're just working on a single product, but what we do is as we add more and more products into the system, we're going to continually train a machine learning and AI model to start understanding the context of it better, and then start understanding, well, if you have polypropylene granulate, it's probably an injection molding manufacturing process. And within the context of each component, understanding, okay, this is a stator, maybe you need steel stamping, and maybe you also need, kind of a sheet rolling process. So what we're really trying to do is combine any knowledge that we have of materials and try to enhance that with the manufacturing process and speed up this process of creating these LCAs. So that way you can have LCAs at the tip of your fingers and kind of really be able to start working more on the eco design portion of it, which is the second screen that I'm going to show. So now that we've mapped this to the LCA databases, you're now able to connect, okay, well, we had this bill of materials and you can see the different levels, blender, it being the first level, the motor, the jar, the housing, the second level, and all the different sub-levels kind of going further down. This becomes useful for your product design and for your sustainability teams to understand, okay, well, now I have this LCA of my product. Where are the hot spots? What are the different impacts that we're looking at? So if you hover over, this is a Sankey diagram. If you hover over it, you'll see this has 11.92 kilograms of CO2 equivalent to make this household blender. If you look at the motor, it's 6.2. So, it's about 50% of the emissions are coming from the motor. So this tells you, okay, this is the component I really want to drill into and understand better. So maybe you want to look into your stator and you're able to drill in here. And you can see, okay, there's these windings in the stator stack. And let's say within the stator stack, well, you have the steel and it goes through the steel stamping process and sheet rolling process. And I'm just going to make a small example of some of the things that you can do and the way that your product designers could think about this in the sense of maybe testing, oh, well, we have this unalloyed steel. What if we were to test another grade of steel or another type? And I'm just going to choose a random one here. But you'll be able to see the switch. And if I do, you'll see what happens if we chose that specific grade of steel and then be able to switch this out. And you actually see the reduction that this is a 23.29% reduction within the stator. And then you can look at these at subcomponent levels and full component levels. And so at the full blender side, that this is a 4.46% reduction. So these are the type of kind of decision making that you would want your engineers to be able to make. And you should be able to swap out, and you can do it in Makersite. What about energy flows? what about different components? If you're in the electronic sector, what happens if we can switch this resistor with this other resistor as they have the same kind of feature set, but may have different kind of materials and manufacturing processes? So you can switch those out and see the impact. So this starts to kind of try to think about how can you manage this at scale. And then you can also do this as a scenario level at scope 3.1 emissions of understanding, well, what happens if this resistor, which is used across 100 products, what if we switch that out? What influence would that have on our scope 3.1 emissions? So this is how you can start to kind of connect to those different data points and think about these impacts at scale. And one thing to note, to Sebastian's point, that of course, oftentimes we're thinking about carbon. It's on front of mind in terms of climate change and the indicators that people care about most. But you don't want to have carbon tunnel vision, so you may want to switch from carbon to water use. And now you can see the difference of switching those metals, where before it was like 4 point something percent. For water, it's 2.65%. And so you can switch between different impact categories as well and try to gain an understanding of what's the benefit of switching X material or X energy flow or X component, and think about these different types of impacts that might be associated with that. And then that's just a pin. You can save it, you can remove it, but this helps you kind of think about from a designer's perspective, and especially if you can feed that information back into your PLM, say Siemens Teamcenter or PTC, and you can feed that information back seamlessly. This allows you to start making those decisions while in the design process, which becomes even more impactful because then you can start making those changes before the product gets to market. Lastly, I wanted to show, or this is the second to last screen, is just thinking about what Sebastian was saying as we're thinking about you have all your purchase orders. Now you're increasingly understanding the impact of all the different components within the products that you're making. So now, rather than thinking about a spend-based approach, you can start to think about, okay, how do we start moving from an average-based method? And finally, how do you get to, okay, well, we actually have supplier information from this. Let's plug that into scope 3. And if you have the right data system, you can kind of build this logic. So you just kind of create a simplified if structure of, if you have primary data, use that. If you only have kind of like the average-based method, do so. And then lastly, okay, fine, lean back on spend base. That's the data that you have available. So what we're showcasing here is just kind of a dashboard example that you have your scope 3.1. So, you have your total inventory, you have it calculated. But now you've connected it to your purchase orders and you have all these different suppliers. Well, now you can group it by suppliers and open that category up. And because now you're increasingly understanding like the data behind that, now you can start to do hotspotting, not just within your products, but you can do hotspotting within your scope 3.1 and say, okay, well, who is the supplier which is leading to the greatest impacts? So within your scope 3.1, you can start drilling in and say, okay, this is from Precision Manufacturing Beijing. This is just a made up hypothetical supplier, or Tap Plastics. So it allows you to kind of really drill into which suppliers are leading to the greatest impact. And then you should be thinking about the next step, what is it that we're buying from them that's leading to such a big impact? And that's where you can drill into the specific SKUs and understand it. And this is the type of functionality that you should be able to have to view into this. And this is what we were talking about when you can trace all three of the numbers and even understand which source that you're using. So to allow for traceability within this as well. So you can see, great, we have our impact from the bill of materials. So what are we using? We're using the BOM-based impact because that's the data that we have available, and so on. And maybe then, okay, when you don't have the BOM, what if you just have your average-based method where you're using kind of like the rough weight and what you think it might be? And then lastly, okay, fine, maybe we don't even have weight. We just know we bought this many units of it for this much. Then that's when you use your spend-based calculation. So you can really kind of use this to create a hybrid-based method to allow you to start to scale the use of LCAs to improve your scope 3.1 reporting and have it be a lot more actionable, because scope 3.1, if it's only based off of spend, just pure inflation would mean that now your greenhouse gas emissions are going up, even though you're probably purchasing the same amount of material. As well as, there's no way to kind of decrease your emissions other than spending less or switching these very generic categories, which are this kind of spend-based categories. So that's the advantage of really moving to scale from using LCAs and PCFs into your products and how it influences your scope 3.1. Yeah, so I think, and the last thing that I wanted to show was if we go back to the Blender, is also some of the outputs. So what does that actually look like when you're replying to your customers? And this is when you might want to have something like an EPD or LCA. So how do you kind of report this, and how do you report this at scale? So that's another way that a solution that you should like that you have. What you should do is essentially be able to kind of report this to your customers in a way that you can do this. For example, might be through PepEco Passport, which is a program operator for these EPDs. And what you typically want to do is be able to kind of save some of this information, bring that information from your ERP systems about, lifetime, what type of product category it is, maybe details around like product electricity consumption during the lifetime. And doing that will allow you then to kind of create these transformable outputs. So for example, we'd have the blender here. You could have all the description of your products. You could have the outputs associated with it. And then, of course, all the impacts there kind of going alongside of that. So that's really how you can kind of move. It's really leading to provide outputs to your customers at scale. So this is all we really wanted to show you and just kind of help kind of provide some food for thought of how to achieve, really providing LCAs at scale by connecting through these different data systems and understanding what type of outputs you could get. And so lastly, we're going to move into a real life example. And so really, just connecting to everything that we just saw, Microsoft is a great case study of this, where Microsoft, for example, has published a lot of reports, on the methodology in which they do LCAs at scale, as well as how they've been able to slash, for example, the new Surface Pro's product carbon footprint by 28%. So within Makersite, they were able to do a lot of these calculations, understand what are the supply chain carbon hotspots, and use that in order to reduce their manufacturing emissions by doing exactly that type of eco-design kind of approach that we were just talking about. And so by being able to do this, they kind of really increase the ability to cover their product portfolio, and at the same time have a lot more kind of accuracy into their actual suppliers, digging into the supply chain and be able to focus on those types of reductions. So really focusing a lot less on doing the modeling and a lot more on how can we do targeted kind of approaches to achieve reductions within the products. So we always just think it's useful to bring a case study up to kind of show how all these things relate and how it's practiced in the real world. And really kind of how they've been able to do it. And their methodology has kind of improved over time. And so what you're able to see is that from 2012 to 2021, they were using Gabi data sets, but they didn't really have that much supplier data. The next thing that they did was really kind of increasingly ask for these FMDs, which are full material disclosures. And if you're able to get these from your supplier, these are actually all the material information that's coming from them. And as you increase that supplier data, that's going to increase your data quality. And increasingly, the more and more that you have of this, more actionable data that you're really able to act on and use that to kind of decrease the emissions associated with your product. So that's kind of been the evolution of Microsoft. And increasingly, we think that's kind of the maturity curve that a lot of, manufacturers really want to go down. So, yeah, that's really all we had to show you today. Thank you for being an attentive audience, and we're happy to answer any questions that you may have.
Awesome. Thank you both for that presentation. That was fantastic. We do have a couple questions in the chat. If anyone else has any more questions, make sure to type them in and we'll get them over. Or if you have any questions that come up later, I'm sure they'd be happy to share their email addresses if things come to you later on. So our first question in the chat is from Roger. So he asked, on slide 26, you mentioned VOM. Kindly expand on the differences and results between the source of EVOM and MVOM.
Yeah, so the way that I would interpret that is the E-BOM is the engineering BOM, where the M-BOM is the manufacturing BOM. Often the engineering BOM, that product is not yet being produced, or at least at scale. It's kind of still kind of like the engineering test phase. So I'd say the results there are more directional, and the purpose of them is to allow your product like designers and the engineers in order to influence what the design would be. So that's kind of more the testing phase. Hey, let's switch out this material and this material. What would the impact of that be? We haven't even started manufacturing it yet, but let's think about it, make the right choice. And then the manufacturing BOM, which is the M-BOM, is much more when this is in the kind of production stage. And now you're making thousands of these. These are who you're sending to your suppliers to tell them, hey, make it like this, because that's what our engineering BOM like kind of was decided on and like declared. Then you have your manufacturing bump. So that's kind of much more the impacts of the products that are actually going to market and being produced. And then that's where you're maybe trying to influence more of the manufacturing processes and like energy efficiency, because that's the real manufacturing process versus kind of the early engineering phase.
That's interesting, Kevin. Thanks for your take on that. And of course, Roger is well aware of the difference between the two kinds of bombs. The one thing that it triggered for me was to perhaps mention Autodesk as having a plugin with Makersite. So there are that thought of giving access to sort of the same kind of data that your LCA team might be working with, but to engineers, to product engineers, to designers in their softwares. That has of course occurred to us and has led to the creation of product solutions. So I think while you can rapidly upload bombs of any kind, EU or M, to Makersite. We do have specific planning phase research and design type solutions in Makersite that are designated for that.
Awesome. Thank you for that. He did have another question. He asked, what are the expectations to achieve ISO 1400 or 44 conforming, sorry.
So the short answer to that is that in general, a systems review or systems review is typically the term that we use to describe how an integrated system of Makersite has to be reviewed, right? So as we have pointed out almost too many times, this is not a one-off study. So you actually don't have the luxury of pairs of eyes to review all of the individual study conditions that would be possible in all the combinations. So what has to happen is that someone looks at that system and verifies that the system works, and so therefore the outputs then are reviewed in that way as well. And of course, there are processes to address that. We are also very actively engaging with the community, out of which we also come as veterans. And so we're trying to push because we believe in the approach, and we're trying to make the industry meet us and catch up, and the standards to catch up to be more specific and create a level playing field for us and any others that want to engage in that LCA at scale field from a standards perspective. So we're very active in that, and at the same time making partnerships with program operators where we establish Makersite as a solution that is acknowledged and is tied into the data flow from Makersite to the program operator system. And so that has started this year, and our first North American customers are even interested in publishing in the European market because that is a very attractive proposal, of course.
And maybe the last, I would just add one more detail to that is just also as well, like exactly for that system verification, that any maybe like implementation that you might do for achieving kind of LCAs at scale, the importance of auditability as you're going through this process. And so we have something called like a QA product matching report, but this is really what we use within the auditing process. And so within every single line of a bill of materials, you can then trace exactly kind of like which data set you map to, how we match that, and then kind of details on like kind of tracking and making sure kind of all those environmental impacts and everything adds up, and the weight percentages and these types of things. So that's kind of how we ensure auditability as we're going through that process, just as a small addition there.
Awesome. Thank you for that. So another question from Matt. Can you share how PCFs that we might receive fit into the modeling that you walk through?
Yes, sure. So PCFs that you receive from your suppliers, there's multiple ways you can do it. I'll just kind of quickly showcase in the platform that we do have an information request platform, and I'll just kind of make a very quick example of this. But for example, we are able to receive PCFs like this. So you can just receive a PCF, add the carbon footprint, add a standard, upload a document. And then we even have like a check that like, okay, well, we understand the current footprint. And if we see it's too high, we kind of have like an error bar warning to understand what what the potential footprint might be. And then if you have just the CO2 like PCFs already supplied from your supplier, we would be able to bring that in just kind of as a carbon flow. One thing that's important to think about is that when you're receiving just PCFs, you lose a little bit of that LCA granularity where you don't have the other impact categories. But it does give you the capability to bring supplier PCF data in, and you would be able to kind of do that quite scalably. So yeah, I don't know if I have too much more to add there, but Sebastian, please feel free to fill in.
Well, I think you did it justice. I mean, that you can create entire campaigns with based on the materials that you're looking for and the numbers that that they are called in your system and on the supplier side. So you can be quite focused in asking specific people for that information, several products parts at a time. And the only thing that we would always encourage is, of course, embedding that in a communication that is not just exclusive to Makersite, but to support your suppliers in providing this and engaging with you on that.
Thank you.
Thank you. This next question is a little bit long, so bear with me as I read through it. But Alexander asked, a lot of our customers are still dealing with incomplete supplier declarations, even after we're able to get through FMDs from some of our primary OEMs. What is a company like Microsoft doing to bridge the gap for the final 30% of missing material data, assuming that 70% is disclosed in their 2023 report? Is Makersite looking into any AI models to help bridge these missing data gaps?
I was just talking to someone internally about a feature that we have that is very interesting, that tries to do just that and use AI to fill gaps in bombs. Of course, you can imagine that is quite tricky, right? But and in fact, the solution that we have in Makersite does not yield the same result in two different instances, but we're working on that and we're pushing on that front. At the same time, a lot of the data manipulation that can happen is before the data enters Makersite. So we were talking about transformation earlier in some of the slides. There's a transformer aspect that takes the data the way that it is available, best available from the customer systems, and basically molds them to the point where they need to be to go into Makersite. And so I can imagine that that is a point at which those bombs can be filled up. Kevin, how do you think about that?
Yeah, I think I'd like to add a couple things here is that we do have a couple sectoral approaches, and I'll move away from relevant and move towards more relevant. But let's talk about the chemical industry quickly. So for example, there's a lot of missing chemicals inside of LCA databases or very complex chemicals that wouldn't even be in carbon mines, for example. So one of the things that we're doing is having an AI model to, kind of do a retro synthesis, break down, what the chemical processes might be in a kind of correct, what's it called? Stoichiometric kind of way to ensure that you're kind of doing the right chemical calculations. So that's one way we're using an AI model, and that's kind of sector specific to chemicals. I'll move into Microsoft and electronics. Is then let's say they couldn't get direct supplier data. If not, we'll look in the marketplace and maybe see, are there IPC files that are available? And this isn't really AI, but more kind of data set availability. Maybe that still doesn't exist. Then what we do is we kind of have a machine learning process called closest match. And we'll look at the features of different electronic components and understand, hey, can we find a very similar electronic, let's say resistor, that has the same resistance, ceramic material type, size, dimensions, and then use that to kind of try to find the closest match. like the closest kind of available, like let's say direct material information we might have. And then very lastly, I mean, what is common that most companies are doing, of course, is just having a proxy EcoInvent or Gabby databases that you just say, hey, it's a resistor and it weighs 4 grams. And to me, that's kind of like the leveled approach to moving from actual primary data to then, okay, we're just going to use an LCA proxy of a market average at this weight, basically.
I think we might have time for just one more question. So this question reads, it seems like your software integrates MDM, a PCF and LCA geared LLM, and analysis/visualization tools. However, it seems like you require a mature ERP and database ecosystem. Obviously, if you could start with better data, that would be ideal. But is there any way to reconcile disparate data and integrate different data sources, such as different facilities reporting their output in Excel sheets and naming things slightly differently, but wanting to analyze them as if they were the same?
Yeah, sure. I mean, I would start by saying that we are not using an LLM, and I mean, there's a lot of like IT and data security issues. So I would just think about it much more of like machine learning, deep learning, because there's a lot of IP issues that go into using an LLM. So want to clarify that so there's not any misunderstanding. It is true. We are focusing on ERP database ecosystems. I mean, we are I mean, if we're thinking of, really the focus of this talk was talking about manufacturing and kind of getting these LCAs at scale. And that's really what we are focused on. But of course, companies are always kind of starting, at a certain point. So like we often refer to this as kind of crawl, walk, run. And then so one of the suggestions on my end would be to start at the Excel files, start to try to understand, do that first model. That makes perfect sense. But then I think from there, what the goal should be is to really start like thinking about where does this data exist? And even if it exists in a lot of different, like you're to the point of like many facilities and all these types of things, is creating some sort of data lake environment. There's also a lot of EHS softwares that exist that can kind of like consolidate this data. So I would just recommend finding a method, whatever method that it is, but data lakes are a common method for doing this, but finding some way to bring this information together, because the more disparate the data is, the more difficult it's going to be to scale and to work with.